How many moles are in 2.89 times 10 to the 27th formula units? When we look at this problem, I first notice that mass, grams, anything like that is missing from the problem. And that's a good thing for us because that means we do not need to worry about a periodic table here. We don't need molar mass or anything like that. So really the one number that we're after here because of formula units is Avogadro's number. Remember that a particle can be lots of things. It can be an atom, it can be an ion, it can be a molecule, and it can be a formula unit as well. And those are the main types of particles that we'll deal with in class. These four here. Now, how are we going to determine where to use Avogadro's number? Well, we're going to let the dimensional analysis, we're going to let the brackets determine that for us. But it is true that 1 mole of really anything, in this case calcium carbonate, has in it 6.02 times 10 to the 23rd formula units. Now the reason we would use formula units over like molecules has to do with the fact that calcium carbonate is an ionic compound. We typically use the term formula units with ionic compounds. It's the smallest form of an ionic compound. And then molecule is used with the smallest form of covalent compounds. That's usually the way it works out. That's really not part of the question, so we're kind of off task here. So let's move on. But we've talked a little bit about that in class. All right, so I'm going to set up my brackets. I'm trying to find moles of calcium carbonate, and the given value is 2.89 times 10 to the 27th formula units. I'm just going to abbreviate formula units, form units. Alright, so we're going to make our brackets. We want to cancel formula units out, so I'm going to put that on the bottom, my denominator position. And we want to find moles, so moles is going to go up on top in my numerator. And here's the conversion factor that I would use. In 1 mole of calcium carbonate, there exist 6.02 times 10 to the 23rd formula units. Formula units are going to cancel. Moles is the unit I'm left with, and moles is the unit that I want to find. So I'm done with brackets, I'm done with converting. Now I have to look at what type of calculation I'm going to make. Well, Avogadro's number is a denominator, so that means that in this problem I'm going to divide. I'm going to divide the 2.89 times 10 to the 27th by 6.02 times 10 to the 23rd. And when I do that, I end up with 4,800.66 moles. But if we're following our sig fig rules, we have too many sig figs in this answer. So we go back and we look. We have 3 here. We have 3 here. Our 1 is infinite, so it doesn't count towards the least amount. The least amount of sig figs is 3. So I need to round this number to 3. And there's my third sig fig, the 0 next to the 8. Next to that 0 is another 0, which means the 0 that's underlined is going to remain a 0. The 4 and the 8 stay the same, the 0 stays the same, and I have to add another 0 for place value. So 4,800 moles is the answer, but I need to make that a significant 0, so I can put a line over it, or I could write 4.80 times 10 to the 3rd moles. In this case I have a trailing 0, so I don't need to put a line over it. Either answer will do. that's how you do a standard particle to mole